Yes, welcome back to Easy Gates Instrumentation Gate 22 Solutions. The next problem, question number 62 from the master paper. That is from electric circuits. Very interesting problem. The problems where you get a good relative advantage between you and other gate aspirants is this. Okay. Yes. That really testing your fundamental. Yes. Very interesting problem. The last one, which tell you it is NMOS small signal voltage gain, and this one based on LC tank circuit. Probably you are familiar with this LC tank circuit, but how he is exploiting that fundamental, we'll see. And finally, we can appreciate the designer for the way he designed this problem. Okay. So in the given circuit shown, the capacitance C0 of 10 microfarad and inductance of L0 1 millihenry, and given an ideal diode, the capacitor is initially charged to 10 volt and the current in the inductor is initially 0. That means the capacitor is energized, inductor has no energy. Okay, so but anyway, we are not going to play with the energy. So that's for a better understanding. Okay, that means the energy transfer is going to take place from capacitor to inductor. Remember that. That is the one going to help us in this problem. The capacitor is initially charged to 10 volt. The current in the inductor is initially 0. If the switch is closed at time t equal to 0 second, yes, this is what going to happen. So the capacitor is holding a potential 10 volt. So switch is getting closed at time t equal to 0 second. The voltage VC of t, voltage across the capacitor is a problem. What is your VC of t? At time t equal to 0.5 seconds. So he's giving, I think, more than enough time. Okay, so 0.5 seconds. The problem is set round off to 1 decimal place. So what's the voltage across the capacitor? So what is the beauty of the problem is there is going to be the current because the capacitor is set to discharge. It is having the energy. It is set to discharge. The current is going to be existing this way. I of t, that's a current through the inductor, but inductor will oppose the current immediately. Probably the current will begin from 0. Okay, I guess so. We'll see. Okay, so what is the voltage VC of t? Assuming diode is on. If diode is on, if you remember quickly where to begin, and capacitor is going to lose a voltage, that means your VC of t has to follow the waveform VC of 0 into cos omega t. That's where the problem actually has to begin. That means the VC of t, the voltage, assuming diode is an on condition. That's very important. Assuming diode is an on condition, the VC of t will fall like this. That means it is going to be a cosine pattern. So what is VC of 0 given? It is 10 volt. Okay, so 10 volt cos omega t. So what is omega? Omega is based on your tank circuit. That omega is equal to, yes, let me get into the next slide. So what is omega? Omega n of the circuit is 1 by root L into C. Let us find out that omega n, it's 1 by root of L is given. L naught into C naught, you can take it as L and C. So it is going to be 10 power minus 3 into 10 power minus 5 it is, because 10 into 10 power minus 6, 10 power minus 5, it is going to be 1 by root of 10 power minus 8. It is going to become 10 power minus 4. We can say 1 by 10 power minus 4. That's going to become your natural frequency. So it is going to oscillate at the natural frequency of 10 power 4 radian per second. What is going to oscillate? The cosine sinusoidal signal. Okay, it's a cosine waveform. So let me take VC of t now. So VC of t is going to have 10 volt cos, otherwise 10 cos. It is going to be 10 cos omega n, that is 10 power 4 into t. Okay, volts. That's how the voltage. Okay, so this is a cosine, so it is going to be like this. Okay, so it is going to start with 10 volt, then going to fall like this. Okay, so assuming diode is in on condition. Okay, assuming it's only LC tank circuit, this is how the capacitor discharge and again charge with respect to the time t. Okay. Then what is going to happen to our current? Because the problem is based on the current. So what is the current I of t? So assuming the current is this way, assuming the current is this way. So this is your capacitor, this is your current. And what is the voltage across the capacitor? We write the expression as V is equal to, otherwise this is the voltage known. Okay, voltage across the capacitor is known, means what is the current? So this is V of t and this is I of t, and you know the Q of t is equal to C into V of t. So then we write I of t as it is dq by dt. We write that is going to be C into dV by dt. Why I'm writing this expression? Because we know the voltage across capacitor. From this, we can find the discharging currents I of t. What is I of t then? It is C into what? dV by dt we will get. It is nothing but dVc of t we can take. What is C given? C given is 10 microfarad. Take that. It is going to be 10 power minus 5. Okay, 10 micro into d by dt of this. What is that? 10 cos 10 power 4 t volts. That's your current. So then I of t is equal to, yes, what we get. So differentiated, it's 10 power minus 5 into, if we differentiate it, it is going to be 10 is cos 10, then cos omega t differentiated, it is going to be minus sine 10 power 4 t into 10 power 4, you will get, let it be the unit of current amps. So I of t is equal to, what do you get? 10 power 4, so 10, so it's going to be 1 amps, so it is going to be minus sine 10 power 4 t amps. And see, there is a chance of committing mistakes. See, my current is down. Because of that, it is coming with the minus sign. Whenever the current is having a negative sign, it means that it is existing in the opposite direction. Therefore, what current we are looking for means we are looking for this current. So therefore, this current is going to be upward. So the current is known now. So let me say the current I of t is equal to sine 10 power 4 t amps. So that is positive. That means it is confirming diode is an on condition. The current is going to exist, okay, from left terminal to right terminal. Okay, that is going to energize your inductor. So the capacitor loses energy, whereas the inductor is going to gain the energy. So now let me plot both the waveforms. So actual current is taken. So now this is the capacitor voltage waveform. So it is falling from 10 to 0. And then like this, it is going. That's a capacitor voltage. This is plus 10. This is minus 10. You can take omega t. Okay, theta you can take. And what about the current waveform? The current waveform, let me plot the current waveform in sync with this. So the current waveform is as given this way. So it is given sine 10 4 t sine omega t it is. So where the current waveform begins, it is going to begin here. It is, there is no phase shift. So this is 0, this is 90, this is 180. So that means the current waveform is going to be something like this, and then going to be something like this. That's your current waveform. That means where the problem is set is, the problem is set at time t equal to 0.5 seconds. Okay, so 0.5 second, what is actually the omega given is nothing but 10 power 4 radian per second. That's a natural frequency. As well as omega we can take, there is no supply, it's only the oscillation frequency of the circuit 10 power 4. That means its time period, assuming 10 power 4, even its time period is going to be approximately 1 by 10 power 4, approximately it is going to be in the order of millisecond. One cycle is going to exhaust within millisecond, but the designer interestingly or intentionally setting the problem at what? 0.5 seconds. Okay, so that means this 0.5 second is not nearly, it is not going to come and play anywhere. We'll see how. So how long this diode will be in on condition? This is the current. Remember that you have a capacitor and this is your diode and this is your inductor. So what's the beauty of the problem? Diode will conduct only for this current. That means till the current is positive, diode will conduct. After that, there is no chance of diode being in conduction. That means how long diode will conduct means how long the current remains what? Positive. That means diode is going to conduct only for this period. Diode will remain on only for this period. Thereafter, diode will never turn on. It is going to be off. That means there is no problem set beyond this point. What does that exactly means? 180 degree. What is that 180 degree? T by 2. What is that T? T is equal to, it is 1 by F. Okay, so there is nothing but what is F? F is 2 pi. F is equal to omega n. So it's Fn. Fn is equal to what? Omega n by 2 pi. If you want to know what is exactly that time period, yes, that's the only time period diode is going to conduct. And what is really the question means, a time t equal to 0.5 second, what is the voltage across your capacitor? That's a question. So how long the diode is going to conduct? Diode is going to conduct only for 180 degree in the circuit, because 180 degree means it's a positive of cycle. So that means the current is going to be competing positive of cycle, then current will start traveling from right to left. The moment it travels from right to left, diode will turn off. That means capacitor cannot charge further, because the energy is flowing from capacitor to inductor, and then inductor tries to push the energy to the capacitor, but diode is not going to allow. That means the circuit is reaching steady state, and capacitor, whatever the voltage at pi by 2, sorry, at the pi with the capacitor, that's a voltage across the capacitor. That is your answer. That's the beauty of this problem. Yes, refer the waveform. At the end of your positive of cycle of the current, diode is going to stop. Okay, after that you won't get this trace, so you won't get any trace of this waveform. Okay, it's not valid. So this is what going to happen. So the circuit, the diode in the circuit is going to conduct only for 180 degree. After that, no conduction takes place, means capacitor will hold a potential of -10. So the answer is -10. -10 is your answer. That's a voltage the capacitor will have. That's the beauty of the problem. Hope you enjoyed this content. That's how the subject has to be approached. That's how your understanding must be. So once you have the fundamentals of basic of how the charged capacitor will discharge in an LC circuit, how the charged inductor will discharge in a circuit, means you have the answer very instantly. Okay. Yes. Okay. It's a numerical answer type problem, and hope you enjoyed. Okay, so that's a way how we deliver things, and hope you enjoyed the content. Once again, I'm asking, and keep subscribing the channel. We'll update you with one more tough problem which happened in IN 22 paper. Thank you.